Hi everyone, and thanks for dialing in today. So process safety management in the offshore wind industry. Why is it important? So the offshore wind industry is growing, and the way we develop projects and the way we consider safety during these projects is also evolving. As we'll discuss throughout the course of this presentation, there are things that we've learned, procedures that we've developed through working in other industries that can be applied to offshore wind assets. We'll also touch on relevant legislation from other industries, current industry guidance, and our own experience and how this has helped developers in the offshore wind industry. So in the last 20 years, offshore wind has come a long way. 2 decades ago, it was an early stage conceptual technology that posed significant economic and technical challenges. Today, it's a proven market, it's well established, and clients can take on projects with commercial and technical certainty. Projects are getting bigger, more places around the globe are being explored, and you can see a few examples on this slide here. In the UK itself, the UK government's net zero strategy shows huge confidence in offshore wind, and it plays a vital role in the green energy revolution in the country. In 2010, 40% of our electricity came from coal. In 2020, that number was down to 2.4%. In 2010, we had around 1 gigawatt of installed capacity. In 2020, that's up to 10 gigawatts. Not only is that enough to power around 7 million homes, it's also the largest installed capacity of any country in the world. We have a target of around 40 gigawatts capacity by 2030, and the UK is home to 7 of the world's 10 biggest offshore wind farm sites. So as we can see, the market is scaling, it's globalizing, asset life cycles are extending, and developers are exploring more challenging environmental waters. So it's clear to see that there's huge potential in offshore wind. But with that huge potential does, of course, come huge responsibility. The responsibility to design and operate assets to the highest safety standards. Whilst occupational safety is something that's always considered throughout the supply chain, what about process safety? How can the fundamentals of process safety be applied to offshore wind and implemented in a way that is appropriate for these assets? The hazards of operating in a marine environment exist across all offshore sectors. Even if we're not used to considering offshore wind as typically high hazard, hazards do still exist, and things can still go wrong. Even though offshore substations are normally unattended, occasional presence is still required, and that means people are exposed to risk offshore, and it's our responsibility to ensure that risk is minimized wherever possible. As installations become larger, more complex, and more remote, we must ensure that process safety is considered at the earliest stages. This is vital to ensuring safe continued operation. So how are we managing process safety in offshore wind? What can we take from other industries to help? We need to create and manage systems and procedures that prevent the uncontrolled release of energy or dangerous substances. We need to identify our hazards early, design them out where possible, and then crucially, understand what our major accident hazards are. Those are the low frequency, high consequence events. And we need to ensure that appropriate mitigation and protection measures are in place. A lot of this language will sound familiar to you, as it's what we use in other high hazard industries, where legislation has really shaped the way we approach process safety. So most of us will be familiar with legislation already in place in various high hazard industries. And when it comes to offshore wind, there are many comparisons that can be drawn with offshore oil and gas, where the Piper Alpha incident in 1988 that took over 160 lives led to the Cullen inquiry and the implementation of the safety case regulations. These require an operator to submit a safety case to the regulator, the HSE, before they can begin operations. The safety case is a comprehensive document that gives full details of arrangements for managing health and safety, and crucially, controlling major accident hazards. We have to be able to show that all major accident hazards have been identified, their consequences are understood, and mitigation measures put in place. When it comes to offshore wind, there are currently no industry-specific regulations or legislation. Instead, we have the Health and Safety at Work Act and the CDM regulations. The aim of CDM is to help developers, designers, and contractors to sensibly plan work from start to finish, ensure that the right people are in place at all stages, and when it comes to risk, ensure that the right information is available on what the risks are and how they are managed. So although both safety case and CDM place an emphasis on risk management, there are differences, with the safety case focusing specifically on identification of major accident hazards and management of these major accident hazards. However, as the offshore wind industry has grown in the UK, the approach the regulator, the HSE, has taken is also changing. So let's look at some current industry guidance. In 2019, two key documents were released. Firstly, we have a guidance note from the Health and Safety Executive in conjunction with the Maritime and Coast Guard Agency on the regulatory expectations for emergency response arrangements for offshore renewable industry. Also in 2019, the G Plus released their good practice guidelines for emergency response. Now, it's important to note that neither of these documents define or mandate new industry standards or requirements, but they do set out an approach that all accountable organisations, be they developers or operators, should be taking. The G Plus sets out a risk-based approach of plan, do, check, act in order to develop robust emergency response plans. And the HSE guidance note sets out principles that need to be adopted to ensure compliance with relevant legislation, and it has been created to essentially assist developers and operators in developing an emergency response plan. While the HSE guidance note does say that the offshore renewable energy industry is not subject to the safety case regulations, it does say that arrangements in place have to be equally as robust as for other offshore industries. So essentially, we don't have to do a safety case yet, but we have to show that we have managed our safety and put our procedures through an equally rigorous process. So there are clearly similarities in what these two documents are saying. They both focus on emergency response and robust planning, but that's not where the similarities end. These two documents also encourage developers and operators to follow a similar and well-established approach when developing their emergency response arrangements. The HSE guidance note says that arrangements should be suitable for any unexpected event and extend to occurrences for the potential for major accident hazard. It even goes as far as defining what a major accident hazard is. It says that arrangements to limit the extent of the incident and reduce the potential for harm should be in place. That is, protection and mitigation measures. And in order to ensure these arrangements are effective, suitable performance standards should be determined. The G Plus good practice says that a risk assessment approach should be used to define credible scenarios, i.e. major accident hazards. Appropriate emergency response arrangements should be in place, and there should be performance standards for these emergency response measures. So what does this mean? It means that we need to identify our major accident hazards, ensure that we have appropriate protection and mitigation measures in place, and ensure that these perform to a minimum required standard. So that's a bit about the current industry guidance. I'll hand over to Emma to explain a bit more about what this actually means for the industry and developers.
Thanks, Heraa, and hello, everyone. So, as you've heard so far, it's clear that offshore renewables developers need to apply the same focus to how they currently consider occupational safety hazards to process safety hazards. So, as Heraa said, occupational safety hazards are typically those hazards that can give rise to an incident that affects one individual. Process safety hazards are those that can give rise to a major accident. So it's clear that developers must embed in the design programme a clear approach to managing process safety in design and throughout the project lifecycle. So let's look at that approach. So, for any offshore installation design, an offshore substation, WTG, at any stage of design, any approach for process safety management needs to cover the elements in dark blue below. So as Heraa said as well, it's about identifying hazards and crucially identifying what the major accident hazards are. It's about assessing the risks of these hazards. It's about demonstrating that the risks have been reduced to as low as reasonably practicable. And then because the guidance note and G Plus is pointing to performance standards, that's about firstly identifying what are the safety and environmentally critical elements, the SECEs, and these are the systems and equipment in place that either prevent a major accident occurring, mitigate its consequences if it does occur, or it could be systems and equipment whose failure could actually cause or significantly contribute to a major accident. So these are things like high voltage protection systems, active and passive fire protection measures, emergency response and evacuation equipment. And then we need to develop performance standards for these safety and environmentally critical elements. And these set out what the minimum standards are in terms of how these systems should function, how reliable they need to be in operation, how available they need to be, and whether they need to continue to function in the event of a major accident, so how survivable they need to be. So these are the main elements of any process safety management approach. But when it comes to an offshore wind farm development that covers a wide geographical area, different installations, different packages, different contracting strategies, how does that work? So it's about defining for each stage of design the particular relevant activities that need to be carried out for a specific package or installation. And that will be different depending on whether it's an offshore substation or a wind turbine generator or a foundation or so on, cabling package. So let's look at the sort of typical activities that could be planned in as part of the process safety management plan. So for identifying hazards, including major accident hazards, well, it could be at an early stage of the design, there could be hazards, NVIDs. Later stages, there could be HAZOPs if there's process systems present, control HAZOPs for control systems. Other design reviews such as layout reviews, 3D model reviews, constructability reviews can all be ways of identifying hazards and major accident hazards. And it's also important to consider lessons learned from other projects or other parts of the industry as a way of identifying hazards. Once we know what the major accident hazards are, we need to assess the risks using any means that is suitable and sufficient. So that could be quantitative means. If there are many sort of process hazards present, it could be a quantitative risk assessment, a fire and explosion risk assessment, or it could be more qualitative or more scenario-based risk assessments, such as maybe looking at dropped object risks associated with crane movements on a transition piece, for example. Demonstrating that risks are reduced to as low as reasonably practicable requires a dedicated part of the approach, and that's about identifying what more could be done to reduce the risks of each hazard, each major accident hazard, and coming to a decision as to whether each measure would be reasonably practicable to implement by weighing up the cost, time and effort of installing that measure versus the risk benefit that will be achieved. And that weighing up could be quantitative, it could be cost benefit analysis, or it could be more qualitative arguments. And the output of that for anything that is considered reasonably practicable will be a feedback look into the design as we incorporate these measures into the design. And of course, that decision, that ALARP demonstration, that decision as to its reasonable practicableness of any measure will depend greatly on the design stage. Earlier in the design, there's more opportunities to implement inherently safer decisions such as layout reviews, for example, which would not be reasonably practicable at later design stages. And then looking to identify the safety and environmentally critical elements, that could be through outputs from risk assessments, it could be from techniques such as bow tie analysis, bow tie diagrams, and then developing performance standards, setting these minimum requirements for performance. That could be design criteria, that could again be outputs from risk assessments, LOPAs, HAZOPs, and so on. So that's the process and the types of techniques that can be used. I want to talk now about how we're currently supporting an offshore wind project in the UK by using our experience of process safety management in high hazard industries. And I'll just talk about the ways that we're supporting this project at the moment. And the first thing that we're doing is exactly what I described in the previous slides. We are defining safety plans on a package by package basis, installation by installation, at each stage of the design. So in other words, what are the particular activities that that package needs to implement at each stage of design to ensure robust process safety management? And we're also defining within these safety plans who leads and who contributes, and that will also depend package by package on the individual contracting strategy of that package. Once we have the activities that we need to do, we're ensuring that these activities are incorporated into the overall project engineering programme with appropriate predecessor and successor tasks in order that we can track the progress of these activities in the same way that all other engineering design activities are tracked. We're also developing a framework of governance, guidance and tools. So, we can develop all the safety plans for all the individual packages, as you can see in yellow at the bottom here. But it's no good if all the packages are performing these activities on a different basis, if they're not consistent throughout. So it needs a framework of governance documents, of guidance documents, of templates to use. So you can see some examples here. We could have hazard guidance, HAZOP guidance, templates for major accident hazard registers, performance standards templates, and the action management process. How are all the actions from hazards and HAZOPs and other design reviews going to be captured, managed and closed out? So we're developing that overall framework. And of course, process safety management is not simply a bolt-on work stream on any design project. It needs to be embedded throughout all engineering design processes. So we're also ensuring that general engineering management processes, such as management of change, such as design decisions, include specific consideration of the effect on major accident hazard risk, as well as general health and safety risks. And finally, we are helping to set the requirements for the supply chain. So once we have the safety plans for individual packages, once we've decided who's leading and who's contributing, we need to set the tender scopes of work accordingly. So we're writing employers' requirements for tenders, and then we're also developing scoring matrices or criteria by which to evaluate the tenders for competency in process safety management. So that's what we're doing to support our UK project at the moment. And of course, the guidance note is a UK regulatory document. So I want to talk a little bit now about how this approach has benefits for any project worldwide. And the first is that by following a rigorous and robust process safety management approach, the project is building up a full audit trail of design decisions, of design justifications, and so on. And that has many benefits. I think firstly, it greatly helps with the process of handover to the operations team to manage the wind farm once the project is complete. It has benefits in terms of if any due diligence needs to be carried out as part of divestment of any part of the wind farm. And crucially, it has benefits in the event that there ever is a major accident. It helps with the incident investigation. By embedding process safety management plans early in any design, it avoids costly redesigns or modifications that need to be carried out to address hazards or operability issues that are only uncovered later. And finally, what we're aiming for here is a safe, operable, maintainable, and viable asset. So before I finish, I just wanted to summarise what you've heard today, which is this. In a rapidly expanding global industry that we have here, the UK regulatory and industry guidance is driving the need for focus on process safety management in the same way that other offshore industries do. And that even though this is a UK specific regulatory drive, there are clear benefits worldwide in adopting these principles now to ensure that risks from major accident hazards across this industry are robustly managed. So I want to thank you very much for listening. I hope this has been interesting for you, and if you have any comments or questions that you would like to ask, then please don't hesitate to get in touch with either Heraa or myself, and our details are on the screen here. Thank you, and bye-bye.